Hello everyone. In my last video, I made an introduction of what indices are, and today we are going to be looking at the 6 laws of indices. 6 laws of indices. These are those laws that if you're able to be able to understand, the solving problems on indices will not be an issue again. Now, what are these 6 laws? We will start with the first one. We'll go right into the video. The first one is the multiplication law. The multiplication law of indices states that when two index numbers are being multiplied, if their bases are the same, pick one base and add their powers. I will say it again. Multiplication law of indices states that when two index numbers are being multiplied, if their bases are the same, pick one base, add their powers. Let me show you what that means mathematically. Now, what this simply means is, if I have a raised to power m times a raised to power n. Now, the bases are the same. What are their bases? A. This one has A. This one has A. Their bases are the same. Their bases are the same. So we are picking one base, the A, and we are going to be adding their powers. Let's use examples to explain this. If I have 2 raised to power 3 times 2 raised to power 4, their bases are the same. So we pick one base, then the powers, we add them up. So this is 2 raised to power 7. Another example, 10 raised to power 3 times, what am I using 3? Let me use 5. Times, let me say 10 raised to power 2. The bases are the same. We pick one base and add their powers. So that will be 10 raised to power 7. As long as the bases are the same, pick one base and add the powers. Thank you. We'll now look at division law of indices. Now, second law of indices is the division law, and it's similar to the first law, which is the multiplication law. Now, what this one is saying is, if two index numbers are being divided, like if they are dividing themselves, once the bases are the same, pick one base and subtract their powers. So it's just similar with the first law, the multiplication law. Just the difference here now is that we are going to be subtracting instead of adding. Remember, when they are multiplying, we add. But when they are dividing, we subtract. So that's just the difference between multiplication law and division law. So mathematically, this is if a raised to power m is being divided mathematically, this is if a raised to power m is being divided by a raised to power n. This is now going to become a raised to power m minus n. So this is what it looks like mathematically. Once they are dividing, as long as the bases are the same, we pick one base and subtract their powers. So using like examples now, using numbers, we have 2 raised to power 3 divided by 2. Now, I hope you know that when you have just a number without any power, the power there is 1, just like s. If I write s, the coefficient of s here is an invisible one. We don't normally write 1s. We don't say 1s as a good mathematician. We just say s. So just like this, we don't say 2 raised to power 1. When you see a number standing alone, just know the power is 1. So look at this. If I have this 2 raised to power 3 divided by 2, this is going to become 2 raised to power 3 minus 1. Their bases are the same, so I will pick one base, then subtract their power. There is an invisible one here. That's why it's raised to power minus 1. So this is going to be 2 raised to power 2. Another example, if I have 4 raised to power 5 divided by 4 raised to power 2, this is going to become 4 raised to power 5 minus 2, which is 4 raised to power 3. Okay, but you know our result here is 4. Why this one is now, we will now check 4 times 4 times 4. 4 raised to power 3 is 4 times 4 times 4. It's not 4 times 3, Most students make that mistake. 4 raised to power 3 is 4 times 4 times 4. That's 4 into 4 times. And I think that should be giving us 64. So this is all about division law. It's similar with the first law. First law is saying when the two bases are the same, if they are multiplying and the bases are the same, you should pick one base and add their powers. While the second one is now saying when they are dividing and the bases are the same, pick one base and subtract their powers. I hope you got that. So we'll be looking at the third law. Ask me, I will say that this third law is the easiest of all the laws and it's very straightforward. Now this law is just saying, this zero index law is just saying that as long as the power of any base is 0, the result is 1. So no matter what the base is, if you raise it by 0, the result is 1. So mathematically this means that a raised to power 0 is 1. So even if I have 2 raised to power 0, the result is 1. 10 raised to power 0, the result will be 1. Even if the number is 1 million, as long as you raise it by 0, the result is 1. That's just the third law, zero index law. And I think that's very cheap. So let's look at the fourth law of indices. Our fourth law is power law. Now, let me state this one. This law is saying that when any number that has a power is again raised to another power, the two powers are multiplied. Let me reframe it. Power law states that when an index number, now when I say index number, you already know it's a number that has a power. I hope you got that in my first video. An index number is a number that has a power. So when a power index law states that when an index number is again raised to another power, the two powers are multiplied. More like if I have a raised to power m. A raised to power m is an index number because it is a number that has a power. If I again raise it to n, I am raising it again with another power. Whenever you have a number that has a power and is raised to another power, what you do is just to multiply the two powers. You multiply the two powers. That's the way we do it. You multiply the two powers. I hope you got that. Okay. And this is our power law. So an example of this is if I have 2 raised to power 3 all raised to power 4. This will become 2 raised to power 3 times 4, which is 2 raised to power 12. So any number you have and is raised to a power and again raised to another power, all you do is to multiply the two powers. Our fifth law is negative index law. Now, this law, negative index law, is just saying that when any number is raised to a negative index, when a number is raised to a negative index, that's a negative power, that the result will become the reciprocal of that number, but raised to a positive index. Let me say it again last time. Negative index law states that when a number is raised to a negative index, the result is that the reciprocal of that number will raised to the positive index. In layman term, in a very clear term, it is just saying that if any number is raised to a negative index, then the result will become the reciprocal. You know what reciprocal means? 1 over. So in layman terms, it's just saying that the result will become 1 over that number. If in case it was 2, it will still be 1 over 2. But then your negative index will now turn to positive. What do we mean? If a is raised to minus m, negative index, this is going to become 1 over a raised to power, no longer negative but now positive. Example, if I have 3 raised to power minus 2, this will now become 1 over. The negative is like what turns to that 1 over. The negative makes it turn to the reciprocal. So we saw this in number base, if you remember. For those that remember their number bases, we saw this number base when we're dealing with decimals. So because of that negative, we write 1 over. Then this number, then raised to positive index, no longer negative. So that means the result here now is 1 over. 3 raised to power 2 is not 3 times. It's not 3 times 2. I hate to ask you and make this mistake. 3 raised to power 2 is just asking you to multiply 3 2 times. So this is going to become 9. So this is 1 over 9. That's our negative index law. When a number is raised to a negative power, what we do is to write 1 over that number now raised to positive power. Our last law of indices is our fractional index law. Fractional index law, that's talking about fractions. So this one now is just saying that when the power of any number is a fraction. Now this one is concerned with when the power of a number is a fraction. So let me state the law. Fractional index law states that when the index of a number is a fraction, that the result is the denominator's root of that number, all raised to the numerator. When the index of any number is a fraction, the result is the denominator's root of that number, all raised to the numerator. What do I mean? If I have a raised to power m over n, the power is a fraction. That this is going to become, my denominator, whatever that the denominator is. Like here now, this denominator is n, meaning I'm going to be taking the nth root. We know what roots are now. We have square roots, cube roots, fourth root, fifth root. Like when we start drawing these things, drawing like this is just the square root. But when I put 3 there, it's not cube root, or you say the third root. When I put 4 there, it becomes fourth root. So this case, our denominator is n, meaning it's going to become nth root. So whenever you have a fraction as your denominator, as your power, your result is going to become the nth root. That's whatever the denominator is, the denominator's root of that number. Then you all raise it to the, what's it called, the numerator. More like take the nth root, take the denominator's root of that number and raise it to the numerator. Example, if I have 4 raised to power 1 over 2. 4 raised to power 1 over 2 is just saying, because of the denominator is 2, it's going to become square root of 4, all raised to 1. So raised to 1 is still the same thing. So this is just square root of 4, which is 2. Another example is if I have 8 raised to power 2 over 3. This is going to become cube root of 8, because the denominator is 3. That's why it's cube root of 8. Then all raised to 2. That's what to do when your index is fraction. So you take the cube root, depending on whatever the denominator is. Whatever denominator you had there will become a root. Then the numerator becomes a power. In this case now, the cube root of 8 is 2. Then 2 raised to power that 2, which is now 4. So if you have been with me up to now, thank you so much. Thank you so much for staying with me up to this moment. If you have been following, I appreciate you. Please comment, like, if there's a way I'm saying it that you don't really understand, ask more questions, ask me to elaborate. I can do that for you, especially in another video. So these are our 6 laws of indices. These are the 6 laws of indices we have. We have the multiplication law, which is saying if a raised to power n times a raised to power n, it is a raised to power n plus n. We have the division law, which is just like that, but just that you are no longer adding, but you are not subtracting. We have the zero index law, we have the power law, we have the negative index law, we have the fractional law. Now, which one would you say is the best of all these laws? The Oga Pata Pata, all these laws. Now, these laws, if you're able to learn these laws and know these laws, it will actually help you to understand it better. Because if you're able to know when to now, knowing these laws is good, but knowing when to apply them is beautiful. If you're able to understand when to apply these laws, when it is multiplication, and when it is division, and when it is power law, or when it is negative index. In fact, whenever you see a negative power, apply negative index. Whenever your power is a fraction, apply fractional index. When two things are multiplying, apply multiplication law. Just like that. That's how it works. So when you see anyone that's looking like any law, you apply the law. Thank you so much. And I always tell my students, practice makes perfect. If you want to be a mathematician, you have to spend time with problems. You have to solve problems easily. It's not our teacher gave us simple one in class. Simple one in class when the assignment is hard. It's because you did not practice well. So learn to practice and you'll become perfect. I hope you enjoyed this video. I hope you have been with me. If you've been here up to this moment, I love you. Thank you so much for being with me. And I hope this helps whosoever that is watching this to learn, to understand indices better. In our next videos, we'll be solving a lot of examples on indices. Please follow me so that you would know when I'm posting the next video. Like, comment, and watch out for the next video. Thank you and remain blessed.